Along with adding actual cable data from Transpower and the conductor data that goes along with that, we've also added in this version of EMO an SFT Calculator. This allows you to play around with the inputs into the SFT calculations, which is particularly useful for what-if scenarios or looking at what might happen in future if lines are, for example, upgraded or reconducted. Now this is available from the Data menu, SFT Calculator. You can look up the circuits that are in the model and select any one that you want to. I'll pick arbitrarily the first one on the list. And what we're seeing are two sets of input data. There's one and another. And then down the bottom we have three fields of output data which are calculated by the SFT calculator based on the two sets of input data. Now the first set of input data are the cable parameters. Now I've pulled up an arbitrary line and it happens to have this particular cable. So I could change that cable and these input parameters below would change. Those are physical properties of that particular conductor. I could also change them if I wished to and if I knew what I was doing individually. Now it's important to note that anything that you enter into the SFT calculator is only used within the SFT calculator. None of this data is actually stored. So you cannot, for example, change the conductor for a particular circuit by changing it in the SFT calculator. Now the next set of parameters are specific not to the conductor but to the circuit itself. You can change the number of conductors, you can change the offload time in minutes, you can change the voltage in kilovolts, you can change the season, and you can change the thermal rating on the cable. I'm just going to close this down and bring up the default for that particular circuit, which is running between Albany and Henderson. So we have this particular conductor. I won't play around with that. But what happens if I add, for example, an extra conductor that's called duplexing this particular circuit? First of all, we need to look at the results of this particular analysis. So these are shown down in the bottom three fields. And the first is labelled Tmax in degrees Celsius. This is the temperature that the cable will reach when it was running at its rated maximum. So in this particular case, Tmax is 80 degrees C, which sounds quite high. In fact, in New Zealand, it appears that the highest temperatures that cables might reach at their maximum rating are around about 120 degrees C. And we have read that overseas in some places cables can run up to 200 degrees C. So let's just suppose that I added another conductor. So we'll put 2 into the number of conductors. And we'll see that for the same thermal rating, the temperature of the cable has dropped significantly. So Tmax has virtually halved, which isn't surprising since we've added another cable for the same thermal rating. The thermal ratings and the amount of sag and the Tmax are all intimately related. Tmax is the temperature the cable reaches at its rating, and its rating is generally set by ensuring that the cable doesn't sag below minimum clearance levels between either the ground or objects on the ground. Now in this particular case, if it was okay for the circuit to operate at 80 degrees C, adding another conductor, we are now only operating at 41 degrees C, so that implies that we could run this particular circuit back up to its original 80 degrees C. So let's have a look how we achieve that. And I'm going to approximately double the rating on this particular cable. So we're looking at about 190 megawatts. And you'll see that the Tmax value has come up to approximately 80 degrees C again. So as you'd expect, adding in one more conductor has effectively doubled the rating on this particular circuit. Now let's go back to the original configuration. So that's one conductor and a rating of 96 megawatts, which gives us a Tmax of around about 80 degrees C. What's the impact of changing the season? Let's go to winter. We have now a significantly lower Tmax. Now what changing the season does, and the only thing that changing the season does, is changes the assumption around the ambient temperature. Some of the assumption is 30 degrees C, shoulder 25 degrees C, and winter 20 degrees C. So in winter, the temperature is lower, which means at the same rating, the cable does not reach the same Tmax. So given that we can get a Tmax of 80 degrees C on this particular cable, we could see that we have room to increase this rating. 105 megawatt rating in winter.